So thanks for joining this snapshot series. Today, we'll be covering the data science and AIOps part, and I want to focus today specifically on time series analysis, forecasting, and anomaly detection as examples. And with this data science package we are offering here, we have actually bridged directly given the possibility to interface with the StableNet data. There is a lot of different data available, like topology data, all the tagging data available in StableNet, and also specifically the time series data from all the measurements. And our intent with this data science package is to make it really easy for the users to access this data and to have not a lot of limitations with what can be actually done with that data in terms of interpretation. Therefore, we are using a Jupyter workbook as one possibility for interactive Python notebooks. There are also other possibilities to use such Python notebooks. As I said, I'm using Jupyter here, and you can actually see me running through these different cells, selecting them, and I can always run those cells, pressing Control Enter, and then I will execute the code. And that way, it's really possible to easily adapt the things to your specific server, to change the credentials to fit your server, and so on if you have that deployed. So it's really easy to use it, and it's also by the nature of Python and a lot of AIOps frameworks available online, it's very easy to integrate additional functionality. So let's run this real quick. I'm just here re-importing the data science package. And in the first part, I'm just setting up a connection to the StableNet server, providing the password, and the rest of it is here in the variables. And now I can already start getting the measurement data. With this command, I can just get all the measurements and get an overview what I have on the server. I actually will skip that here, but here I show an example to access a specific set of measurements using a tag filter here, like a contains tag filter, asking for all the measurements containing a name with example interface. And I'm running this here, getting a total of 5 measurements. I will also sort and display them. So I can see that I have actually created on my server for this webinar 5 example interface measurements that some of those I will choose for today's use cases. I also have here some additional possibilities of just, for instance, extracting the IDs of the different measurements if I want to work with a list of IDs. So it's just here different possibilities to access the data. Now, let's directly not spend too much time here on this loading of the data, but directly look a little bit into the data. So now, for that purpose, I'm picking one of these measurement IDs, the 13926 here, and I'm actually asking for the last 180 days. Start time is last 180 days and the end time is today. And I'm requesting that data using that command here. So I get a data set of 41 different metrics and 2087 rows, which means that I have 2087 values for these for each of these metrics. And now I will actually, this is just another command to iterate on several measurements. I will also skip this. I'm just working in the continuation with this one data set here with interface data for now. And now I will visualize this interface data. So I'm running this command here, takes a short moment. And here I'm, for instance, just showing the different metrics over time. Takes a short moment because I have this large data set. And then in a second, you will see what was already there, which I just rerun now. You will see here the different metrics in different colors, one below the other. For each metric, you have the title of the metric in the legend. And you also have the values. You can, for instance, see here that on the server where I'm working on, the data is being aggregated because if I go more to the past, I have the averages are closer together, so it's not varying so much. If I'm looking at the more up-to-date data, the variation is larger. And you can also get an overview here of all the data, like all below the graph, you have a legend, which is also indicating the time. So it's like the last 6 months. and this can be used as a first base to get a better understanding of the data. And now we can also pick, let's say, one specific of these metrics. So in this case, I have picked the average in utilization, so the incoming utilization in % of this link. And I'm just accessing this interface data on the target column average in utilization. So I get a plot here about the data. And I can then also, we are using here, this is the nice thing about Python, that we can be using ready available components here. So you can, for instance, drill in and get a view on the last month, the last week, and last day, and so on and so forth. You can also do this with the mouse, so you can really zoom in and get an understanding. So maybe this was like for the first 5-6 minutes, this was a general overview of getting the data and looking into it a little bit. And now directly in the workbook, I want to go into the first use case, like looking a little bit more into anomaly detection. So to that end, I'm again picking one of the measurements from above, in this case, the one with the ID 22, and with the target column average out utilization. I'm looking at the last 20 days in this case, and I'm again running my command. So I'm again getting, as this is again an interface measurement, I'm getting again 41 columns, but I'm actually getting in this case more data than I had before, because I picked here a measurement which has a more dense data available. And now I will actually, in the next 5 minutes or so, I will run through different anomaly detection algorithms one by one. And we will actually see together that all of these different anomaly detection algorithms have different mathematical statistical approaches they are using. So for some outliers, they might be very well fit to see the anomalies, and for other outliers, they might be not adequate. This obviously also depends on the data set, and I want to just give a quick overview on some of these algorithms, and the notebook can also then is containing, for some of them is containing links, for instance, to Wikipedia to read about more details. So let's start with the first one here, which is a threshold-based anomaly detection. This is basically resembling exactly the functionality of StableNet, that you have lower and upper thresholds, and if thresholds are exceeded, you will get an error. And I'm just rerunning this here again with the data set. And you can actually see I have chosen the lower threshold to be 0 to eliminate it, basically, in this case, because all the utilization is obviously beyond 0. So there is no red point on the lower end. But I have chosen the upper threshold to be 0.3, so 30% utilization, which is here looking into this graph. The white lines are at 20 and 40%. So just in the middle between those two, I have my my threshold. And what you can actually see here, if we are looking at that data set, you can actually see that this data set seems to have a normal day-night behavior, which is this sinus-like curve that is going here that I'm following with my mouse. And at the same time, there seems to be like smaller peaks where it's suddenly increasing in between. And if we are looking now at the threshold-based anomaly detection as expected, everything which is just beyond my threshold will be considered an anomaly, no matter if this might be a normal day-night behavior or if this is like a short outlier. So if we are considering that these might be the outliers we want to look at, this is not the most adequate approach. So now the next one I have here is a quantile-based approach. Is basically the exact same thing as the threshold-based approach, with the only difference that it's not a fixed value, but it's a quantile-based value. So I'm actually looking at all sorts of outliers which are going beyond the, in this case, the 97% quantile. So all values that are belonging to the largest 3% are highlighted. And I can see here when I'm looking at this area, I can see that I'm highlighting both the short outliers and the long curve here. So it's also not ideal. And now I'm actually in the next minutes, I'm not executing everything again to speed up a little bit, or I can just execute this one again. So this one is a persistent homology anomaly detection. This stuff is getting more and more tricky in the statistics part, but this is now something which is actually looking at changes of previous values and having, as you can see already, quite a list of parameters to work with. As I said, more information is also available on Wikipedia. And now you can see that we suddenly approach a goal to find more these specific anomalies with short time changes and don't consider those ones as anomalies. And this is continued here. You have further algorithms. As I said, not all algorithms are fitting for each data set. This one, again, doesn't seem to be fitting very well. The local outlier one is, again, selecting. At some points, it seems very odd what it's selecting. I think this level shift here is quite adequate as well, where you can really see that it finds a lot here. So as I have said in a nutshell here, there are a lot of different anomaly detection algorithms which can be found online, some of which are proposed also by large machine learning engines and freely available. And with this data science package, it's possible to use these in a very easy way. You just basically change your server credentials, access your local server, and then you can analyze your data further with that these mechanisms. Yeah, there's the last one. I think this one is also not fitting very well for my data set. And now for the last part here, for the last few minutes, I want to really look into forecasting real quick. In this case, I'm using Facebook Profit, which is the thing it has to do with Facebook is that's a library provided by Facebook to be used by everyone for forecasting. And in this case, I also have the possibility to use my existing time series data and look at the historical data, and based on this, Profit is calculating a forecast on how the data might further develop, also considering periods like seasonal influences. So first, I'm defining some parameters here, like for the future, I want to do a forecast for the next 20 days and look into seasonality. And I'm again working with the average out utilization, but with another measurement. So I just picked a measurement here that fits well for this purpose. And what I see here, actually, if this is loading, the black dots are the actual measurement values. So this is what is actually available as measured data. The blue line is the forecast starting with a fit of the available data. So here you can see, as I'm moving my mouse up and down, you can see that this is a day-night behavior that is recognized and included in the trend. And on the right side of the graph, you can actually see that there are no measurement points anymore because there's like a forecast to the data. So in this case, I seem to have used the data set, which is only lasting until the 8th of January. I don't have a forecast. I don't have data for that last week, but here these 2 weeks are forecasted without the data. And you can actually see that the forecast is on the one side following that day-night behavior, and on the second side also showing a general trend. And the last command that I have here in that notebook is actually showing the different components of this forecast. On the one side, we have a trend component, which resembles a little bit the trend calculation that we also have in StableNet in the backend, which is basically indicating how strong this is growing or decreasing. And on the second side, you have a daily seasonality. So it's actually recognizing that the data set seems to have a day-night behavior, which is roughly following such a structure, like going down in the morning hours and then increasing for the evening hours. And this is also calculated here. So summing up, this was just a quick run through this data science notebook, but it's showing that for you as a user, it's very easy to integrate it. You just can provide your server credentials. If you have this Jupyter environment running, you just have to provide your server credentials and then can connect to your StableNet server, and from there on take your data to for instance, do all the analysis that is shown here in the notebook, or also extend it on your individual needs. And this is also final statement. This is also obviously laying a base for future developments that we can, based on this now, see how the usability can be further improved and what can be potentially integrated more closer into StableNet in the future. But here with this, we are already laying a foundation for this to give you the chance to be very flexible with this. Thank you very much.